Good morning, guys. Today I'm going to go through a GraphQL tutorial. I'll be learning GraphQL today from scratch. I've never looked into GraphQL, and one of my clients uh, want to develop using GraphQL. So they want to serve all the resources from their server using GraphQL instead of the traditional API. Anyway, so this is an attempt to learn GraphQL and see if I can help out the client. So to begin with, I went to the GraphQL.org website, and I'm going to get started. So GraphQL, the website itself talks. I'm in the home page. It talks about. I don't know if you can see. Let me make the screen a little bigger. Anyway, it talks about what GraphQL is about. As you can see, it's saying you can describe your data at a high level and ask for what you want. Okay. So looks like, I don't know what this means, but maybe as I go through, I will figure out what this means. And then it's asking about, it's saying my results will be predictable. Looks like here, so it looks like here they created a type called project. Looks like the name is string. So there is a name field in the project, and there is a tagline, and there are contributors who are users, I guess. So this is the data structure. I think looks like you create some kind of a data structure, and using the GraphQL program, I'm guessing this is the input. If I provide an input like project name, GraphQL, and tagline, it'll give me back the tagline. Okay, so that's what this is saying. So in the results, I see what I got back. So basically, I'm getting a tagline back, which is called a query language for APIs. So maybe GraphQL itself provides a way to query. I'm guessing this website itself provides a way to query it, I guess. Anyway, we'll know more as I go through the rest of the documentation. The second part of it says, okay, basically it describes GraphQL in a little more detail. It says a query language for your API. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more, and makes it easier to evolve APIs over time, and enables powerful developer tools. Cool. Basically, they're saying it's a query language for your API, where so your API can provide customers the data, whatever the data that they really need. So right now, if you take a look at a lot of the REST APIs, they dump a lot of data back, they respond with a lot of data back, and only a portion of the data could end up being used by the client side. So this one is saying that, hey, make a API call, and then let's say you ask for a name, it's only going to give you the name. If you ask for name and height, looks like it's only going to return the name and height. So you don't have to version your REST APIs and stuff like that. Basically, your GraphQL API will take care of it. So that's what I think in this section they're talking about. Ask for what you need and get exactly that. So it's saying send a GraphQL query to your API and get exactly what you need, nothing more and nothing less. GraphQL queries always return predictable results. Apps using GraphQL are fast and stable because they control the data they get, not the server. So again, it's saying Send a GraphQL query to your API and get exactly what you need, nothing more, nothing less. This is really good. So it's going to reduce the amount of the data that goes over your network, goes over the internet to the client. GraphQL queries always return predictable results. Okay, so looks like they always return predictable results. Basically, if you ask name, height, in this case, they're asking for name, height, and mass, weight, I guess. So it's only going to return those three fields. Apps using GraphQL are fast and stable because they control the data they get, not the server. So get many resources in a single request. GraphQL queries access not just the properties of one resource, but also smoothly follow references between them. So what this means, let me maximize the screen. So what they're saying is get many resources in a single request. GraphQL queries access not just the properties of one resource, but also smoothly follow references between them. Okay, so I can not only make a GraphQL API that will not only return my name, but looks like I can make it return all my friends and their names also. In one query, I can get a big object with all this data. While typical REST APIs require loading from multiple URLs, GraphQL APIs get all the data your app needs in a single request. Okay. So instead of making a call for my name and then making another API call to get my friend's name, GraphQL API can just get all of it in one shot, is what they're saying. Apps using GraphQL can be quick even on slow mobile network connections. Okay. Yeah, they will be quick because I think instead of making multiple round trip calls over the network on mobile, basically you use the 4G, 3G connections, and then network connection on mobile over the cell network is pretty unreliable. So instead of making multiple calls, you make one call so that, hey, you get it in one call. So the second call, it doesn't have to do a handshake, and all the network traffic over network is pretty slow. I think the less number of network calls you make, the faster your application will be. So GraphQL is going to return data in one call instead of 5 calls. So that means it's close to 5 times faster. So describe what's possible with a type system. Okay, so looks like they have a type system. So you can say, okay, let's see. GraphQL APIs are organized in terms of types and fields, not endpoints. So looks like we define types and fields. So I think a type, let's say I have a type called query, and looks like query has a field called hero, and looks like character is the data type, I'm guessing. So anyway, so the character itself is another type. So I have a query, basically hero is a field inside of it, and we are saying a hero is nothing but a character. And then a character itself is another type, and it has a field called name, and friends called character types. So it's an array of characters. And then it has homeworld, another type called planet, and species, another type called species, I'm guessing. So planet is a type with a name and climate. Both the fields are strings, and species is another type with three things in it. The first one is a name, the second one is lifespan, and the third one is origin. Is another planet. Okay. So looks like this is the type. This is the type system for a sample GraphQL API, and then I think this is the input. I guess if I query something like this, I get back. I get back the data that I'm querying for. In this case, I'm saying, hey, I want all the queries. I'm guessing. I'm guessing this means I want a type of hero, and I want the names of all the characters who are heroes, and all the friends of this character, and the friends' names, and home world. I don't know how this is structured. Home world, species. Oh, home world is a type. So I not only need the name of the character, I want um, the friends home world, which is a type of planet, and I want the friends species. Species is another type. Home world itself has name and climate. So basically, what I'm saying here is I'm querying for all the hero characters. I want the hero character's name. I want the hero character's friends, and the friends is nothing but an array of characters. So I want the friend's name, and I want the friend's home planet, and the friend's home planet has a name. I want the name of the home planet and the climate of the home planet, of the home world, which is nothing but a planet data type. And then I also want the friend's species, and the friend species type has a name, lifespan, and origin. So anyway, so at a high level, that's how we structure a query, I guess, and a type. So move faster with powerful developer tools. Know exactly what you need. Know exactly what data you need. Oh, sorry. Know exactly what data you can request from your API without leaving your editor. Highlight potential issues before sending a query, and take advantage of improved code intelligence. GraphQL makes it easy to build powerful tools like GraphIQL by leveraging your API's type system. So looks like GraphIQL is a tool. Let me see what kind of tool it is. So GraphQL, oh, it's an in-browser IDE for exploring GraphQL. So it's an in-browser. So let's see. I'm going to open a live demo. Okay. So looks like here I can explore the swap SW API, Star Wars API Graph IQL. Okay. Oh, so looks like this is talking about how to create a UI. So this one, this Star Wars one is for that particular GraphQL API. I'm guessing this is for the Star Wars domain. They're saying if I want to create my own GraphQL Explorer or whatever they call it. So I can use this project to create my own GraphQL Explorer. So they not only have that, so looks like they have a check out the example in this repository, which also includes a few features highlighting GraphQL IQL API. So I wonder what this is. GraphQL example GraphQL install. Blah blah blah. Navigate to this directory in terminal. Open your browser. Oh, okay. So I can try something like this also, I guess. I will explore creating this after reading the documentation. I'll just go back to the documentation. So basically, they provide a UI to test your GraphQL APIs before publishing it, and then maybe you can make changes based on what you discover. So evolve your API without versions. Okay. So which is good. So basically, you can evolve your API without versions. Right now, you have to, every time you change your API, you have to version it to make sure that people who are using the older version can continue to use the older version. You can't just overwrite it and break people who depend on your API. So looks like we can evolve the API without version. So basically, so they're showing it. So in my API, if I want to add or delete something, so I can. Okay, so they're showing one way how I can create a type and either add new types to my API, or looks like here they also remove stuff from my from APIs. So they added or they removed a director from one, and instead of that, they put it directed by. Okay. Cool. So we'll explore that more when we dig into an example. So bring your own data and code. GraphQL creates a uniform API across your entire application without being limited by a specific storage engine. Write GraphQL API that leverage your existing data and code with GraphQL engines available in many languages. You provide functions for each field in the type system, and GraphQL calls them with optimal concurrency. So what they're saying here is bring your own data. So bring your own data and code. So, right. So that's showing three ways of defining a type and how you code the type. I think this one is Python, and this one is Java, and they're showing how you define your type, and then how to code it in JavaScript, and how to code it in Python here, and how to code it in Java. So basically, they're saying, hey, you can bring your own language, use your own language, and develop your APIs using your own language. So there are GraphQL engines in many languages is what they're saying, and that's what they're showing here. You provide function calls for each field in the type system, and GraphQL calls them with optimal concurrency. Okay. So they talk about who is using GraphQL here. They're saying Facebook. Facebook's mobile apps have been powered by GraphQL since 2012. A GraphQL spec was open sourced in 2015, is now available in many environments and used by teams for all sizes. So it looks like they talk a few more things about it, who is using it and stuff like that. So it looks like Facebook has been using since 2012 and they open sourced it in 2015. Now, I think we'll go to this learning section and see how I can learn this. The learning section. So they start with an introduction to GraphQL. They say learn about GraphQL, how it works, and how to use it in this series of articles. Looking for documentation on how to build a GraphQL service, there are libraries to help you implement GraphQL in many different languages. So I'm guessing we'll develop in Node, at least for the server side. So we'll see how to do it in Node. So GraphQL is a query language for your API. So I'm going to increase the font a little more. So they're saying GraphQL is a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. So it looks like the query language, GraphQL is nothing but it has a query language for your API and a server-side runtime for executing your queries by using a type system that you define for your data. Okay. GraphQL isn't tied to any specific database or storage engine and is instead backed by our existing code and data, backed by your existing data encoder. So it only specifies a type system and you make the query, you call the query from the client side based on the type system, and that the GraphQL engine that you'll end up writing on the server side will take the query, and then it can make a call to whatever your data, wherever your data is. Your data can be in whatever database or flat files, it doesn't care. So the server side kind of isolates the client side. So we can keep the existing data. You don't have to create a new database or anything like that. Your data can be in multiple formats. The GraphQL server-side code will take care of querying the data from your disparate data sources. So the only thing we'll be writing is a server-side implementation of how the API will interact with the client. We'll see that a little more. So a GraphQL service is created by defining types and fields on those types, then providing functions for each field on each type. For example, a GraphQL service that tells us who the logged in user is, as well as that user's name, might look something like this. So basically they're saying a GraphQL service is created. So we create the service by defining types and the fields on those types. Here, if we see, they defined a type called query, and inside that there is a field called me, and me is nothing but a type of user. And when we go to the type user, again, a user type is user type has fields ID, which is ID. I don't know what kind of data type that is, but and a user type has a name field, which is nothing but a string. So what they're saying is, for you to build a service, you create types and fields inside that, inside those types, and then providing functions for each field on each type. So if someone wants to query users, looks like if someone wants to query me, then we write a function, and then the function will do so and so. And same thing for username. So if we have a user object on the client side, we can make a call and find out, hey, what is the user's name? To find out the user's name, we would do something like this. Once a GraphQL service is running, so let's look at everything. So once a GraphQL service is running, typically at a URL on a web service, it can be sent GraphQL queries. So once we have a GraphQL service that is running, so we can send GraphQL queries to validate and execute. You're saying a received query is first checked to ensure it only refers to the types and fields defined, then runs the provided functions to produce a result. For example, the query me name could produce the JSON result. Okay. So in the above example, if someone is querying with something like this, then we return basically the name of the user. Learn more about GraphQL, the query language, the type system, and how the GraphQL service works, as well as best practices for using GraphQL to solve common problems in the articles written in this section. Okay, I don't know what they mean by this. In this section is where. Okay, so we'll go to the next one. I'm sure as we go through, we will figure out what they're talking about. Queries and mutation. On this page, you'll learn in detail about how to query a GraphQL server. Fields. At its simplest, GraphQL is about asking for specific fields on objects. Let's start by looking at a very simple query and the result we get when we run it. So they're saying at the simplest, GraphQL is about asking for specific fields on objects. So in this case, he's asking for the hero in the hero type, they're asking, hey, I want the name of the hero. And this one, it returned back with inside the hero, they're basically saying R2D2 is the name of the hero in this case. You can see immediately that the query has exactly the same shape as the result. So he's talking about, okay, I think the shape is similar. By that he means, hey, hero, I'm querying for hero name, and I got back the hero object with a name field inside of the hero object. This is essential to GraphQL because you always get back what you expect, and the server knows exactly what fields the client is asking for. So he's saying, hey, so returning exactly what the client requests is, they're saying it's essential to GraphQL. So basically, if you query for hero and name, you only get back hero and name, nothing more, nothing less. the field name, they're saying the field name returns a string type. In this case, the name of the main hero of Star Wars R2D2. Oh, one more thing. The query above is interactive. That means you can change it as you like and see the new result. Try adding an appears in field to the hero object in the query and see the new results. Oh, so this is interactive. Okay, so let's say I add appears in. Oh, okay. So as soon as I typed appears in, I got back another field, which is an array showing all the movies. I'm guessing these are all the movies, Star Wars movies that R2D2 appears in. In the previous example, we just asked for the name of our hero, which returned a string. But fields can also refer to objects. In that case, you can make a subselection of fields for that object. So instead of, yeah, so if you see, I think they're asking for an object, but they're asking only for the name only for the name field inside objects. They're not asking for anything more. So it looks like that's exactly what we got back here. We got the hero object, the name at a high level, and friends, an array of friends, but the array of friends only includes name. I'm guessing if I want more, I can I don't know what else is available. Oh, friends connection. Oh, let's say I want friends of friends, and oh, it's an object. So I want name. I wonder what will happen if I do that. Okay, so I got back friends, an array, and Luke Skywalker and his friends. So basically, I can create a hierarchy like this. Note that in this example, the friends field returns an array of items. GraphQL queries look the same for both single items or list of items. However, we know which one to expect based on what is indicated in the schema. Okay. Arguments. So if the only thing we could do was traverse objects and their fields, GraphQL would already be a very useful language for data fetching. But when you add the ability, I will wait for the plane to move on. But when you add the ability to pass arguments to fields, things get much more interesting. So it looks like you can pass arguments to fields, and then it will filter. So instead of getting all humans, I'm guessing if I do this, I'll get all humans, I guess. Oh, there's nothing like that. Oh, okay. So this human type requires you to pass an argument. So if I say I want human 100, oh, there is no one with human 100, only 1,000. Let's say 1,001. Darth Vader is 1,001. Okay. So I can pass an argument, and then it will filter on that argument. I wonder if there is any way to do like a star and get everything back. Okay. So it's showing me the human with ID so and so. So it looks like this human, I don't know how they coded it. Maybe they coded it to always, it requires you to pass in an ID, but we'll see it later. So in a system like REST, you can only pass a single set of arguments. So the query parameters and URL segments in your request. But in GraphQL, every field and nested object can get its own set of arguments, making GraphQL a complete replacement for making multiple API fetches. You can even pass arguments into scalar fields to implement data transformations once on the server instead of on every client separately. So they're talking about something like you can pass in scalar arguments like this also. So I wonder if there is something like inches instead of, oh, there is only foot and meter. So let's say, what will meter return? Okay, it's saying the height in meters is this much. And if I do it in foot, which is nothing but feet, I guess. So it's saying Luke Skywalker is 5.6 feet. In meters, if I want meters, I think it's saying it's 1.72 meters. Cool. Arguments can be of many different types. In the above example, we have used an enumeration type, which represents one of a finite set of options. In this case, units of length, either meter or foot. GraphQL comes with a different set of types, but a GraphQL server can also declare its own custom types as long as they can be serialized into your transport format. So they talk more about GraphQL type system here. Let me open this real quick, but we won't digress from what we have here. Okay, so they talk more about the type system, which we will eventually get to, I'm guessing. So I'm not going to dwell into it too much. I'll also close these other distractions. So aliases. So if you have a sharp eye, you may have noticed that since the result object fields match the name of the field in the query, but don't include arguments, you can directly query for the same field with same arguments. That's why you need aliases. They let you rename the result of a type of a field to anything you want. Okay. So what are they aliasing here? So they created, so if they want to create an alias for the hero type, but filter on episode empire, you can do something like this. I wonder if I can create another alias called, let's say Luke. I want to create another one called Luke, where I'll say human with ID 1000, and then I want the name. Yep. So here I created an alias called Luke with name Luke Skywalker. So looks like this is one way you can create aliases, and this is what will be returned. It's much more easier to consume, I guess, on the client side. So in the above example, the two fields would have conflicted, but since we can alias them to different names, we get both results in one request. So basically, I think something like this can't be done. So that's the reason why you need aliases, I guess. So it's complaining, saying that fields hero conflict because they have different arguments. Use different aliases on the fields to fetch both. So because this is a duplicate, you won't allow, because you don't want to have, yeah, you can't have a duplicate field in a JSON object. So let me correct that. Okay. The next section, they talk about fragments. I think in fragments, they're saying, let's say we had a relatively complicated page in our app, which let us look at two heroes side by side, along with their friends. You can imagine that such a query would quickly get complicated because we would need to repeat the fields at least twice, one for each side of the comparison. That's why GraphQL includes reusable units called fragments. Fragments let you construct sets of fields and then include them in queries where you need to. Here's an example of how you could solve the above situation using fragments. Let's read this fragments thing again. Fragment says, let's say we had a relatively complicated page in our app, which let us look at two heroes side by side. Along with their friends. You can imagine that such a query could quickly get complicated because we would need to repeat the fields at least twice, one for each side of comparison. Okay. That's why GraphQL includes reusable units called fragments. So basically, if I want to compare the hero in episode Empire with the hero in episode Jedi, I can have a fragment called comparison fields that I can define as a fragment as a fragment called comparison fields on a particular type of data. And then I'm saying that, hey, I only want name appears in friends and their names. So GraphQL includes a feature called fragment, which can be used to get data, similar data for in two different aliases here. So left comparison in one alias and right comparison is the other alias. Let's see how the data looks. I think data basically, the hero in episode Empire is Luke Skywalker. He appears in these movies, and his friends are Han Solo, Leia, C-3PO. Right comparison, the hero is R2-D2, and they appear. R2-D2 appears in these things, and R2-D2's friends. So you can see how the above query would be pretty repetitive if the fields were repeated. The concept of fragments is frequently used to split complicated application data requirements into smaller chunks, especially when you need to combine lots of UI components with different fragments into one initial data fetch. Okay. Variables. So far, we've been writing all of our arguments inside a query string. But in most applications, the arguments to fields will be dynamic. Yeah. So based on user changes, I have to change my query. Maybe I have to pass a variable to the query. So let's see. For example, there might be a drop down that lets you select which Star Wars episode you're interested in, or a search field, or a set of filters. It wouldn't be a good idea to pass these dynamic arguments directly to the query string. because then our client-side code would need to dynamically manipulate the query string at runtime and serialize it into a GraphQL specific format. Instead, GraphQL has a first-class way to factor dynamic values out of the query and pass them as a separate dictionary. These values are called variables. Okay. When we start working with variables, we need to do three things. Okay. So to use variables, looks like we need to do three things. Replace the static value in the query with $variable name. So declare variable name as one of the variables accepted by the query. And pass variable name value in the separate transport specific variables dictionary. Here's what it looks like altogether. Query hero name and friends. And looks like this is the variable they're talking about. I wonder why we could not use something like this. I wonder what the difference between this and this is. So here we are passing it statically. So basically we are hard coding Empire here. Suppose if you want to pass this in a variable, then looks like we have to do some setup like this. Okay. So instead of on the client side, instead of constructing a new query each and every time, we can pass. So let's say I want the data for Empire, all the hero in the Empire episode or in the Empire movie of Star Wars. Then I would have had to create a query for Empire, and then if I needed the hero object for Jedi, then I would have to create another query. Instead of that, looks like I can create a query like this, and I can pass in a variable, and that will take care of it. And it looks like this. So this gets passed here, and this is the variable name, and the variable name gets values like, in this case, it'll get values like R2D2, or sorry, it gets values like what is this movie name? Empire or Jedi. Oh, here. Okay, this is the variable they're calling with. Okay, let me see if I can pass Empire and see what will come back. Okay. As you can see, if I passed in Empire, I got back something else. So what else is available? Okay, so New Hope is also available. If I type New Hope, I get back the hero of New Hope and their friends. Jedi was what was there. Okay. For Jedi, I got back that. Okay. It's I just type one character and it's filling it. There is no S, so it's telling me, hey, pick one of them. Okay. So now in our client code, we can simply pass a different variable rather than needing to construct an entirely new query. Okay. This is also in general a good practice for denoting which arguments in our query are expected to be dynamic. We should never be doing string interpolation to construct queries from user supplied values. Okay. Variable definitions. The variable definitions are the part that looks like episode in the query above. It looks just like the argument's definition for a function in a typed language. It lists all of the variables prefixed by $, followed by their type. In this case, episode. Episode is a type. I thought it's a simple string. Okay. I think something enumerated types, I guess. So you're passing it values like Jedi, Empire, and stuff like that. So those are enumerated types. So all declared variables must be either scalars, enums, or input object types. Okay. So if you want to pass a complex object into a field, you need to know what input type that matches on the server. Learn more about input object types on the schema page. Okay. So basically you can pass for variables, you can only do scalars, enums, or input object types. Variable definitions can be optional or required. Variable definitions can be optional or required. In the case above, since there isn't an exclamation next to episode type, it's optional. But if the field you're passing the variable into requires a non-null argument, then the variable has to be required as well. So use the exclamation to make it required, or yeah, if it requires non-null argument to evaluate the query, then it's required as well. To learn more about the syntax for these variable definitions, it's useful to learn the GraphQL schema language. The schema language is explained in detail on the schema page. We will learn that as we go through. Default variables. Default values can also be assigned to the variables in the query by adding default value after the type declaration. Okay. So you add a value like that, huh? So they're assigning a string. So this is supposed to be a enumerated type, like without the double quotes. But anyway, when default values are provided for all variables, you can call the query without passing any variables. If any variables are passed as part of the variables dictionary, they will override the defaults. Obviously. So basically you give a default by doing something like this, but you can always, if you pass in a new value, it will override the default value. Operation name. One thing we also saw in the example above is that our query has acquired an operation name. Up until now, we've been using a shorthand syntax where we omit both the query keyword and the query name. But in production apps, it's useful to use these to make your code less ambiguous. So looks like in some instances, this query name was not specified. I think it started out without this, I think. So it was only using something like this. So they're saying that it's a good practice to use, to define your queries with a name and whatever the optional variables it's being passed. So if the query has a name, then I think they recommend it for production, and yeah, it tells exactly what the query is about. Giving a name to a query is good. Think of this just like a function name in your favorite programming language. For example, in JavaScript, we can easily work only with anonymous functions. But when we give a function a name, it's easier to track it down, debug our code, and log when it's called. In the same way, GraphQL query and mutation names, along with fragment names, can be useful debugging tool on the server side to identify different GraphQL requests. Yep. I think we should always provide a name to query, mutation names, fragment names. Directives. We discussed about how variables enable us to avoid doing manual string interpolation to construct dynamic queries. Passing variables in arguments solves a pretty big class of these problems. But we might also need a way to dynamically change the structure and shape of our queries using variables. For example, we can imagine a UI component that has a summarized and detailed view where one includes more fields than the other. Uh, so looks like we can give directives like this, and then based on this, it will either retrieve the data or not retrieve the data. So we discussed about how variables enable us to avoid doing manual string interpolation to construct dynamic queries. Passing variables in arguments solves a pretty big class of these problems. But we might also need a way to dynamically change the structure and shape of our queries using variables. For example, we can imagine a UI component that has a summarized and detailed view where one includes more fields than the other. Let's construct a query for such a component. So it looks like something like this can be included to either show this friends object or not. So if you pass something like this, and if the hero is queried with episode Jedi and with friends false, because friends is false, it's not giving the names of the friends. But if I change this to true, oops, yeah, it gives me all the friends. Okay. So looks like This at friends is what can be used. At friends with if can be used to filter out friends. Try editing the variables above. Instead, pass true with friends and see how results change. Yeah, we already did that. So we needed to use a new feature in GraphQL called a directive. A directive is something like this, I think. At something. At include with if is the directive. Okay. So a directive can be attached to a field or fragment inclusion and can affect execution of the query in any way the server desires. The core GraphQL specification includes exactly two directives, which must be supported by any spec-compliant GraphQL server implementation. So all the core GraphQL specification includes two directives, exactly two directives, which must be supported by any spec-compliant GraphQL server implementation. So we should allow user to do, allow user to filter using something like this, I guess. Only include this field in the result if argument is true. Skip this field if argument is true. Okay. So include or skip, include and skip can be used. Directives can be useful. Directives can be useful to get out of situations where you otherwise would need to do string manipulation to add and remove fields in your query. Server implementations may also add experimental features by defining completely new directives. So mutations. Most discussions of GraphQL focus on data fetching, but any complete data platform needs a way to modify server-side data as well. So not only we need to query, we need to also figure out how to modify the data. In REST, any request might end up causing some side effects on the server, but by convention, it's suggested that one doesn't use GET requests to modify data. Obviously, you'll use POST or PUT in REST to modify data. GraphQL is similar. Technically, any query can be implemented to cause a data write. However, it's useful to establish a convention that any operations that cause writes should be sent explicitly via a mutation. Just like in queries, if the mutation field returns an object type, you can ask for nested fields. This can be useful for fetching the new state of an object after an update. Let's look at a simple example mutation. So they're talking about a mutation. So saying use mutation whenever you're updating data. So here a mutation called create review for episode was created, and it takes two arguments. I think the first one, the episode one, is required. Oh, review is also required. So basically, I think for this episode, yeah, anyway, we'll see what they're doing. Create review. Okay. And they're passing in the episode and the review. I think review is the input, I think. Stars, commentary. Okay. I'm guessing this is the review part is the thing that gets modified. This is the data that will be modified or updated. In this case, maybe review is being added to an episode of Jedi. And then it returns that back, basically. It's returning the create review object with two fields in it, stars and commentary. Okay. So note that create review field returns the stars and commentary fields of the newly created review. This is especially useful when mutating existing data. For example, when incrementing a field, since we can mutate and query the new value of the field with one request. Okay. You might also notice that in this example, the review variable we passed in is not a scalar. Okay. What are they talking about? Oh, yeah. It's an input object type, a special kind of object type that can be passed in as an argument. Okay. So this review object is not a scalar. So we are passing. So if I change this to something like this, will it still work? What is the error it's showing? Expected value, but found Jedi. Okay. Okay, we are sending episode review. We are passing in an input object instead of a scalar, is what he's saying here. Multiple fields in mutations. A mutation can contain multiple fields just like a query. There's one important distinction between queries and mutations other than the name. While query fields are executed in parallel, mutation fields run in series one after the other. This means that if we send two increment credit mutations in one request, the first is guaranteed to finish before the second begins, ensuring that we don't end up with a race condition with ourselves. Okay. Basically, if you have multiple mutations on multiple fields, they run in sequence instead of parallelly to avoid a race condition. I think, let's see. I don't know what that really means, but maybe they'll have an example down there somewhere that says exactly what that means. Inline fragments. Like many other type systems, GraphQL schemas include the ability to define interfaces and union types. If you're querying a field that returns an interface or a union type, you will need to use inline fragments to access data on the underlying concrete type. It's easiest to see with an example. So here he's creating a query called hero for episode, and episode is a required field. And then inside of that, he's returning the hero object with the episode that's passed in, and he's going to return the name. And he has a fragment called droid, and that one It's doing something called primary function. I wonder what that means. And there is another fragment called human. And from that human, he's only returning height. Or from droid, he's only returning primary function. Okay. So if I change this to empire, I get something back. Okay. I wonder if there's anything else available here. Hmm. I don't know the structure of droid, but I don't know. We are getting name and height. I thought we are supposed to get primary function also here, but it's not showing primary function. I don't know why. So I get the name, I'm getting height, but not primary function. Hmm. I wonder what the definition of this droid is. Anyway, so in this query, the hero field returns the type character, which might be either a human or a droid, depending on the episode argument. Ah, okay. So if I change this, it'll return only one of them, it seems. Okay. So Jedi, what's the other one? New Hope. Okay, let's pick New Hope. Yeah. So for New Hope, I think it picks the, so it'll either return this or this based on if the hero is a droid or a human. Hmm. In this query, the hero field returns the type character, which might be either a human or a droid. Depending on the episode argument, in the direct selection, you can only ask for the fields that exist on the character interface, such as name. To ask for a field on the concrete type, you need to use an inline fragment with a type condition. Because the first fragment is labeled as dash 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 on droid, the primary function field will only be executed if the character returned from hero is of the droid type. Similarly, for height field for the human type. Named fragments can also be used in the same way. Since a named fragment always has a type attached. Meta fields. Given that there are some situations where you don't know what type you'll get back from the GraphQL service, you need some way to determine how to handle the data on the client. GraphQL allows you to request __ type name. a meta field at any point in a query to get the name of the object type at that point. So given that there are some situations where you don't know what type you'll get back from the GraphQL service, you need some way to determine how to handle the data on the client. GraphQL allows you to request dash dash underscore underscore type name, a meta field at any point in a query to get the name of the object type at that point. Okay. Looks like if you have a search, I don't know what search means here, but if you have something like this with dot dot type underscore underscore type, it's saying it's a human. So if I have something like droid, nothing, huh? ID. If I just say X1, what will do? It's searching on name, and if this person, oh, X1 is a starship, so its type is a starship, so it's printing out the type of object it is. So if I type AN, I think so AN is in advanced, here it is in Leah Organa, and then it is in AN. It's returning all three of them and their types. I do not understand where I would use something like this, but looks like you can get some meta information like the type of the object that's being returned using this underscore underscore type. In the above query, search returns a union type that can be one of the three options. It would be impossible to tell apart the different types from the client without underscore underscore type name field. GraphQL services provide a few meta fields, the rest of which are used to expose the introspection system. Okay, whatever the introspection system is. Okay, so I think we will eventually get to the introspection system, I guess. So basically it's saying, okay, so these are the meta, these are the meta tags I can use to introspect, I guess. I don't see type. Oh, type is the second one. Okay. There is type name. I don't know. Anyway, so I'll take a break for a few minutes and then we'll look at schemas and types. Okay, I'm back. So this next chapter is about schemas and types. On this page, they're saying we'll learn about GraphQL type system and how it describes what data can be queried. So since GraphQL can be used with any backend framework or programming language, we'll stay away from implementation specific details and only about the concepts. So it looks like they'll only talk about concepts. Okay, the type system. If you've seen a GraphQL query before, you know that the GraphQL query language is basically about selecting fields on objects. So, for example, in the following query, so we start with a special root object. We select the hero field on that. So I don't know what they mean. I'm guessing the root object is this in this case. And they're saying we'll select the hero field on that. For the object returned by hero, we select the name and appears in fields. Okay. So we are going to only select name and appears in. Because the shape of a GraphQL query closely matches the results, you can predict what the query will return without knowing that much about the server. So basically, without knowing the server, you can kind of, based on your query, you know exactly what will come back, is what they're saying. But it's useful to have an exact description of the data we can ask for. What fields can we select? What kinds of objects might they return? What fields are available on those sub-objects? That's where the schema comes in. So basically, if we know the description of the data, then they're saying we can query for the fields better. Every GraphQL service defines a set of types which completely describe the set of possible data you can query on that service. Then, when queries come in, they are validated and executed against that schema. Okay. Type language. GraphQL services can be written in any language. Since we can't rely on a specific programming language syntax like JavaScript to talk about GraphQL schemas, we'll define our own simple language. We'll use the GraphQL schema language. It's similar to the query language and allows us to talk about GraphQL schemas in a language agnostic way. So basically, because they don't want to tie you down to a specific language, they created their own GraphQL schema language. And that's what is used to specify the types and fields, is what they're saying. Object types and fields, the most basic components of a GraphQL schema are object types, which represent a kind of object that you can fetch from your service and what fields it has. In the GraphQL schema language, we might represent it like this. So this is a representation of a GraphQL type, object type, and the fields inside of it. So here they're saying they're defining a GraphQL object type called character, and it has two fields. The first field is name, and its data type is string, and the exclamation, as we read before, exclamation means it's a required field. And appears in is the second field inside this character type object. Appears in is an array of episode, array of objects of type episode, and this is also a required field. The language is pretty readable, but let's go over it so that we can have a shared vocabulary. Is a GraphQL object type, meaning it's a type with some fields. Most of the types in your schema will be object types. Name and appears in are fields on the character type. That means that name and appears in are the only fields that can appear in any part of a GraphQL query that operates on the character type. I'm eating breakfast, late breakfast. Sorry if sorry if you hear a lot of crunching noise. They're saying the string type, the string data type here, they're saying that string is one of the built-in scalar types. These are types that resolve to a single scalar object and can't have sub-selections in the query. Okay. String exclamation means that the field is not nullable. Okay, it's not nullable. Not. I thought it means it's not required. So anyway, the string exclamation means the field is not nullable, meaning that the GraphQL service promises to always give you a value when you query this field. In the type language, we'll represent this with an exclamation mark. So they put an exclamation mark to say that, hey, this is not nullable. So episode with an exclamation represents an array of episode objects. Since it is also not nullable, you can always expect an array with 0 or more items when your query appears in field. Makes sense? Now you know what a GraphQL object type looks like and how to read the basics of the GraphQL type language. Arguments. Every field on a GraphQL object type can have 0 or more arguments. For example, the length field below. Looks like every field on a GraphQL object type can have 0 or more arguments. So looks like when you define your type, when you define a type and fields inside of it like length, you can say that, hey, you can give it a default unit. I wonder where length unit is defined and what kind of enumeration it is and how it looks. So all arguments are named. Unlike languages like JavaScript and Python, where functions take a list of ordered arguments, all arguments in GraphQL are passed by name specifically. In this case, length field has one defined argument called unit. Arguments can be either required or optional. When an argument is optional, we can define a default value. If the unit argument is not passed, it will be set to meter by default. Understood? How to make the argument required? I wonder if exclamation here will, like after unit, if I put an exclamation, that makes the argument not optional. Anyway, we'll see more later, I guess. The query and mutation types. Most types in your schema will just be normal object types, but there are two types that are special within a schema. So coming back to the query and mutation types, most types in your schema will just be normal object types. There are two types that are special within a schema. Looks like these two are special. Let's see what they're talking about. Every GraphQL service has a query type and may or may not have a mutation type. That's understandable. So you don't have to, if you're only querying a system, and if the GraphQL service is not going to let you update, so then they only have a query based system. These types are the same as regular object type, but they are special because they define the entry point of every GraphQL query. So if you see a query that looks like this, So if looks like if I have a query like this without a name, so this defines the entry point for every GraphQL query, it seems. Anyway, I will know what that means a little later, I guess. I change this to 1000. Okay. I change this to 2001. Does it return anything? Okay. That means that the GraphQL service needs to have a query type with hero and droid fields. Oh, this is the query object itself. This is saying that the GraphQL service itself needs a type with query where you can query on hero and query on droid. This is how you set it. If you put an exclamation at the end, that means it's required. So if I take this out, I doubt it'll work. It's showing an error saying that, hey, syntax error expected, blah, blah, blah. Okay, so if I take out this also, this field droid argument ID of type ID is required but not provided. Yep. So if I have, if the user gets to invoke a query like this, create a query object like this, that means they are saying that the GraphQL service need to have a query type with hero and droid fields. So we need something like this, is what they're saying. So mutations work. They're saying mutations also work in a similar way. If you define fields on the mutation type, and those are available as the root mutation fields, you can call in your query. It's important to remember that other than the special status of being the entry point into the schema, the query and mutation types are the same as any other GraphQL object type. And their fields work exactly the same way. So it's important to remember that other than the special status of being the entry point into the schema, the query and mutation types are the same as any other GraphQL object type, and their fields work exactly the same way. Okay. I don't know what that means, but anyway, we'll learn more a little later, I guess. Scalar types. A GraphQL object type has a name and fields. But at some point, those fields have to resolve to some concrete data. So looks like I missed sharing the screen, I think. So let me start over from the top real quick. Basically, this one is schemas and types. Here they talk about the type system. Basically, they're saying the user can write a query like this, and basically we get back a hero object. I think there will be a one-to-one correspondence. If you're querying for only hero, they get hero, and inside hero, if we need name, we get back name. and appears in is another field we want, and it returns the field. And they show if you want to define in your service, if you want to define a character object type, this is how you define it. And this one basically says, hey, my type is character, name is a string, exclamation is not nullable, and appears appears in is again not non-nullable. It returns an array of objects. It'll at least, it's guaranteed to return an array with it's guaranteed to return an empty array, basically zero or more values in the array. And they talk about arguments. So when you define your object type, you can define your objects. Basically, again, if you have an exclamation, it means that it's not nullable. And then they're saying if you want to if any particular field in your object can take an argument, you can do something like this: open parenthesis. This is length is a field, and you can open a parenthesis and define the arguments it will take. So in this case, unit is one of them. So if you define a default value, so we are saying that, hey, unit is of type length unit, and the default value is meter, is what this is saying. So all of them, all the arguments that you pass to a field have to be named arguments. So they won't take it like JavaScript or other systems like that. You have to name the arguments explicitly. Like here it's called unit. So you need to do something like that. And in the query and mutations, basically there are two types. There are two types of objects. One is called the query and the other one is called mutation. So these are, they're just like normal objects, but they're special within a schema. So we'll see why. So every QL service has a query type. So they're saying every QL, if you want to query for Hero and Droid, you would do something like this. You would create your object like this, and it'll return data like this. For something like this to work, they're saying that your reserved query, basically query is the entry point. They're saying that the default query is the entry point. So you have to have a query with, at a minimum, Hero and Droid objects. And anyways, if you define in your service, if you define a type, an object type called query with Hero and Droid, then you can make a query like this, is what they're saying. I doubt I can add something else here. Let's say human. I don't know if this will work. ID is okay, this is working because I think the query type that's defined in the service that's using this this window, I'm pretty sure it has human also. Let's say if I say human2, will it work? So human2 doesn't work, cannot find human2 on type query. So looks like the query defines all the types that you can query on. So it looks like if we have a query with objects Hero and Droid like this, that means you can query on Droid and Hero. So mutations work in a similar way. You define fields on the mutation type, and those are available as the root mutation fields you can call in your query. It's important to remember that other than the special status of being the entry point into schema, the query and mutation types are the same as any other GraphQL object type, and their fields work exactly the same way. They're saying other than being entry points, there is nothing else difference between query and mutation. And obviously, mutation is used to manipulate an object or update an object. Query is strictly used to query the object. So it's a read-only API. Mutation is using a mutation, you can write to the data. And here they talk about scalar types. Scalar types, a GraphQL object type has a name and fields, but at some point those fields have to resolve to some concrete data. That's where the scalar types come in. They represent the leaves of the query. So I think scalar types are nothing like a string is a scalar type. Basically, you can't. So let's say you define your field called name as a string. Name cannot be an object, as in it doesn't have any. It cannot have any subtypes, is what they're saying. Those are the scalar types they're talking about. So we know this because those fields don't have any subfields. Yeah. So a scalar field doesn't have any subfields, is what they're saying. They're the leaves of the query. So GraphQL comes with a set of default scalar types out of the box. So int is a scalar type, float is a scalar type, string, boolean are scalar types because they can, none of these can have subfields. ID is also, oh, so by the way, string is a UTF-8 character sequence. So int is a signed 32-bit integer. Float is a signed double precision floating point value. So they only have like a few data types, but in most cases that should be good enough, I think. So the ID scalar type represents a unique identifier often used to refetch an object or as the key for a cache. The ID type is serialized in the same way as a string. However, defining it as an ID signifies that it is not intended to be human readable. So ID represents a unique identifier. So looks like it will identify some object uniquely, I'm guessing. So okay, so an ID type is serialized similar to a string. So they are like a UUIDs or GUIDs. Sometimes they call them globally unique identifiers. So I think they represent a unique identifier, and looks like they're represented. They can be serialized similar to how a string is serialized. So so you can read it, but it will be like gibberish. Anyway, so it is printable, I think, the ID itself, but other than that, I don't think it's its own data type. In most GraphQL service implementations, there is also a way to specify custom scalar types. For example, we can define date type. Oh, okay. So looks like you can define a custom scalar type called date. Then it's up to our implementation to define how the type should be serialized and deserialized, deserialized and validated. So if you define a scalar called date, I'm guessing it will be a string representation of a ISO. It will be a ISO date string, and you can use it to serialize and deserialize, and then validate, making sure. I mean, if it's an ISO date in a string format, you can serialize it, deserialize it, and validate it also. For example, you could specify that the date type should always be serialized into an integer timestamp. Okay, so you could do that also, and your client should know to expect that format for any date fields. I don't know how you'll represent date in an integer format. Maybe seconds from I wonder if seconds from 1970 will it fit in an integer anyway? So maybe you could do something like that, I guess. So let's see. So if I have something like this, so if I want to represent it in an integer, so let's say, oh, here in this case, it's a number, I think, right? I don't think there is anything called integer in JavaScript. In 32 array, but there is no integer data type. Oh, so I have a parse int. And then I'll say new date. So actually I'll create a new date and then I'll say let n equals I want to say parse int, and then I'll say date dot I think there are multiple. I think there is value of, and there is also what is that? Should be able to use that, but let me see if there is anything better than value of. Okay. Okay. There is this UTC milliseconds. Value of n. Yeah. Okay. And already defined it. Okay. So it is fitting it in an integer. Anyway. So we can also see what is a signed integer 32-bit. So it can take up values this big. So parse and it value of. So let me see what I get back. So 3, 6, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's much bigger. So it won't fit in a signed integer, but anyway. So at least in JavaScript, I don't think I can serialize it to an integer. It can't be serialized to an integer timestamp in JavaScript, but it can be serialized to an ISO date string. And enumeration types, also called enums. Enumeration types are special kind of scalar that is restricted to a particular set of allowed values. This allows you to validate that any arguments of this type are one of the allowed values. Yeah, just like any other enumeration type, I think. So you can define a bunch of, um, you can give your enumeration a name and um, define the values of your enumeration. Yeah, communicate to the type system that a field will always be one of a finite set of values. So this means that wherever we use the type episode in our schema, we expect it to be exactly one of New Hope, Empire, or Jedi. Okay, when we define an enumeration type like this, they're saying this means that whenever we use the type episode in our schema, we expect it to be exactly one of New Hope, Empire, or Jedi. Otherwise, the Explorer, the GraphQL Explorer was throwing an error. I'm sure the GraphQL API will also throw an error. Note that GraphQL service implementation in various languages will have their own language-specific way to deal with enums. In languages that support enums as first-class citizen, the implementation might take advantage of that. In a language like JavaScript with no enum support, these values might be internally mapped to a set of integers. However, these details don't leak out to the client, which can operate entirely in terms of the string names of the enum values. Okay. So it looks like whenever we use an enum to filter, we have to assign it the string value of the enum. And in JavaScript, I think the internally on the service side, the enums will be represented with strings 1, 2, 3, 4, or maybe it can start with 0. I wonder if JavaScript support for enums is coming. I don't know what this means. Let's see. There are what is called symbols. Okay. So looks like this is one way enumify better enums for JavaScript. So this is one way to define fake a enum, I guess. Looks like there is a library called enumify that can be used in JavaScript because we will be doing something in JavaScript. I wonder if we can use that. Uh, anyway, so there are multiple ways of doing it, I guess. Okay. Anyway, so one way to do it is through using that enumify library, I guess, in JavaScript. And this the one I'm looking at is some documentation on MDN. How to create enums, I'm guessing. I don't see anything. Normal objects and functions, indexed arrays. I'm going to search for enum and see if there is anything. Anyway, I'll skip this for now. We'll get back to the class, get back to the learning part of it. Note that GraphQL service implementation in various languages will have their own language specific. Okay, we already read this. They're saying in JavaScript you could use integers to map values in objects, and that's how you can do it. Or in our case, we might end up using the enumify library. Lists and not null object types, scalars and enums are the only kind of types you can define in GraphQL. But when you use the types in other parts of schema or in your query variable declarations, you can apply additional type modifiers that affect validation of those values. Let's look at an example. Here we are using list and non-null. Okay. So basically they're saying object types, scalars, and enums are the only kinds of types you can define in GraphQL. So you can define either a type or a scalar or an enum. You can't do anything more than that. I think scalar, for defining a scalar, we did that scalar date. And for enum, it's like it starts with an enum keyword. And that's it, I think. So you can define either a scalar, an enum, or a type. Those are the only things that are available in GraphQL. But when you use the types in other parts of schema or in your query variable declarations, you can apply additional type modifiers that affect validation of those values. Let's look at an example. So they gave an example of an object type called character. It has two fields, one called name, one called appears in. Not a not nullable, and it's a string, and appears in is an array, and it's array of episode object types, and it is not nullable either. So here we are using a string type and marking it as not nullable by adding an exclamation mark after the type name. This means that our server always expects to return a non-null value for this field. And if it ends up getting a null value, that will actually trigger a GraphQL execution error, letting the client know that something has gone wrong. So for whatever reason, if the service ends up putting a non-null, a null value, there will be a GraphQL execution error. And the client will see the error, I'm guessing. So the non-null type modifier can also be used when defining arguments to a field, which will cause the GraphQL server to return a validation error if a null value is passed as that argument, whether in the GraphQL string or in the variables. Okay. So here is a query, and it's saying that, hey, it takes one argument, ID, and they have an exclamation. So that means they're saying that droid by ID, you have to pass it an ID. If you don't pass it an ID, then it will throw an error. So if I pass it 2000, then it should work. But if I pass it null, also I think if I pass something like null, it will throw an error. So but if I pass it a string called null, thinks it's valid, but it's basically it didn't find it. So a string null and a null, two differences. I think null is throwing an error. Lists work in a similar way. We can use a type modifier to make a type as a list, which indicates that this field will return an array of the type. In the schema language, this is denoted by wrapping the type in square brackets. It also works the same for arguments where validation step will expect an array for that value. The non-null and list modifiers can be combined. For example, you can have a list of non-nullable strings. Okay, how is it different here? Oh, okay. So this is a non-nullable array, and this is a, I don't know if you can see the difference, but let me make it a little smaller. So if you see the difference between this and something like this, so it looks like this is a list of non-nullable strings, and the episode one up above here of it's an array that's not nullable, and this is a array that cannot have any strings that are nulls. That is my understanding anyway. So let's see what they say. This means that the list itself can be null, but it can't have any null members. For example, in JSON, something like my field is null is valid. Okay, so basically this can be null by itself, and something like my field is an empty array is also valid. An array with two strings is also valid, but an array with one null and two other strings is not valid. Now let's see. Now let's say we defined a non-null list of strings. That means that the list itself, this is a non-null list of strings. That means the list itself cannot be null. Okay, the list itself. So basically, if they put the exclamation outside, okay, this is the difference. I think my field here and this my field here. If you see the exclamation here is outside the array and here is inside the array. So that's saying this means the list itself is not nullable, but you can have contents that are contents inside the list can be nulls, is what I'm guessing. Yeah, so that's what they're saying. So the list, you can't null the list itself. The my field cannot be null, but it can be an empty array. It can be an array with 2 valid strings, and it can also be an array with 2 valid strings and 1 null. Even this is valid. The only thing that's not valid if you put exclamation outside is you can't null it. That's pretty straightforward. You can arbitrarily nest any number of non-null and list modifiers according to your needs. Okay. I wonder if I can do, I don't know if this will let me change it. I wonder if I can put a exclamation inside and outside. In that case, I'm guessing this will be an error and this will also be an error. So interfaces, like many type systems, GraphQL supports interfaces. An interface is an abstract type that includes a certain set of fields that a type must include to implement the interface. For example, you could have an interface character that represents any character in Star Wars trilogy. So they support interfaces also. Like many type systems, GraphQL supports interfaces. An interface is an abstract type that includes a certain set of fields that a type must include to implement the interface. Okay. For example, you could have an interface character that represents any character in the Star Wars trilogy. So instead of making this a type, you can always make it an interface. So a character, yeah, and a type can inherit from it, I'm guessing. So it can implement the entire thing. Let's see how this is done. Again, they defined an interface called character, and they have one field called ID, which is not nullable, name, string that is not nullable, and friends. It's a list of characters nullable and appears in a list of episodes not nullable. So this means that any type that implements character needs to have these exact fields with these arguments and return types. For example, here are some types that might implement character. So they defined a human that implements character. And to implement a character looks like they have to duplicate each and every field that is in character. So they duplicated ID, name, friends, appears in, and they added 2 additional fields, one called starships and one called total credits. And there is another one called droid. Droid also inherited the first 4, implemented the first 4 fields, and then it has one additional field called primary function. You can see that both of these types have all of the fields from character interface, but also bring in extra fields, total credits, starship, and primary function that are specific to the particular type of character. So interfaces are useful when you want to return an object I think I did a control F on something and it took me somewhere else. Sorry about that. I was trying to do a control F on this, control copy, control F, control V. Okay, so it can highlight the character thing. And you can see, yeah, basically we implement the character, and the character is inheriting all these fields. You can see total credits is an extra field like starships. So interfaces are useful when you return an object or set of objects, but those might be several different types. So they're saying interfaces are useful when you want to return an object or set of objects, but those might be of several different types. For example, note that the following query produces an error. So looks like this is producing an error. We don't know. I don't know the definition of. I don't know what is the type of hero, but in earlier examples we saw that a hero, if it is only a droid, then they'll have a primary function. So if I change this to, let's say, Empire, I'm guessing it'll work. Maybe not. Oh, Empire also doesn't have a primary function. So New Hope. So New Hope should work, I think. Maybe not. Cannot query field primary. Okay. Oh, okay. So this will work only on the droid. Okay. So let's see what they have to say. So this is throwing an error. The hero field returns the type character. Okay. So this is returning the type character, which means it might be either a human or a droid. Oh, okay, okay. So it's returning a character, so it can be a human or a droid, depending on the episode argument. Okay. In the query above, you can ask for fields that exist on the character interface, which doesn't include primary function. Okay. To ask for a field on a specific object type, you need to use an inline argument. So this is called an inline argument, I'm guessing. So I can only do dash dot 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 on droid. Then it will tell me. So droid is another object type, and it has primary function. So basically, if the hero is of character type droid, then only give me the primary function. Otherwise, ignore is what this is saying, I'm guessing. So this Empire should also work. So Empire, basically, it's not showing the primary function because Empire is the main character is Luke Skywalker, and Luke Skywalker is a human. So we'll be able to get, if I type something like this on human, then I should be able to get height, I think. I was able to get, so if it is, if hero is of type human, we get height. If the hero is of type droid, we get primary function. So if I change this to Jedi, I get R2D2. R2D2 is a droid, so I get primary function for that. To ask for a field on a specific object type, you need to use an inline fragment. Okay, this is still called a fragment. Yeah, that's what I'm thinking. So these are fragments, droid and human. So I think we'll have to review this once more to get a handle on, hey, what is a fragment, and Why do we do a fragment here? Is the fragment also does the fragment here also implement the interface called character here? I don't know. So let me quickly check. I don't talk about how they implemented this on Droid fragment. Okay. Oh, okay. So basically, I can have a fragment called Droid on character, and it returns me either what were the two, primary function or height. If it's a fragment on human, I think it'll return something, and if it's a fragment on Droid, then I want to get primary function. Okay. So union types are very similar to interfaces, but they don't get to specify any common fields between the types. So union types, looks like they're using a union keyword. They created a union type of search result. This could be either a human, droid, or starship. Whenever we return a result, search result type in our schema, we might get a human, a droid, or a starship. Note that members of a union type need to be concrete object types. You can't create a union type out of interfaces or other unions. In this case, if you query a field that returns the same result, union type, you need to use a conditional fragment to be able to query any fields at all. Okay, union types, whenever we need to, okay. So here, looks like we created a union type of search result. So if you query a field that returns a search result, union type, you need to use a conditional fragment to be able to query any fields at all. Okay. So this is going to search for AN in human. And if it finds AN, then it's going to return name and height. If it'll search droid and return name and primary function, starship name and length. I wonder how it knows that it needs to search in the name field and not some other field. So input types, so far we've only talked about passing scalar values. like enums or strings as arguments into a field. But you can also easily pass complex objects. This is particularly valuable in case of mutations, where you might want to pass in a whole object to be created in the GraphQL query schema language. Input types look exactly the same as regular object types, but with the keyword input instead of type. So this is talking about if you want to pass a complex object, then we use what are called the input types. This is particularly valuable in case of mutations, where you might want to pass in a whole object to be created in the GraphQL schema language. Input types look exactly the same as regular object types, but with the keyboard input instead of type. Okay. Here is how you could use the input object type in a mutation. So basically they're passing in this review input, and int is not nullable, commentary is a string, it is nullable. So they can give some kind of stars to the review. And then the create review will obviously insert it, I'm guessing. So this is how a review object was created, and that is what is being passed. Wherever we have a dollar, that's the variable, and the variable type. Okay. I have to relearn from JavaScript. And in JavaScript, basically, you can just pass $EP and $review. But here, I have to relearn the syntax. Basically, I think it's kind of strictly typed. The variable has to be of type episode, and this review variable has to be of type review input. That means it should follow the syntax. So if I send something like a string here, I'm pretty sure it'll fail. Yeah, so it's throwing an error, which is a good thing. Less errors in production. So the fields on an input object type can themselves refer to input object types. So this commentary can itself be another input object type, but you can't mix input and output types in your schema. Input object types also can't have arguments on their fields. Okay, input is strictly input. There's no reason for you to filter any input object, so that makes sense. So again, going through this, I think there is a using the input keyword, we can create an input type object. This is used for sending the input, especially in mutations. And then I don't know, I didn't understand the search property, but you can use the union keyword and create a data type, a type which is a union of multiple, I think in this case, fragments or objects, I guess. And when you search, you need to use the fragment to filter out the data that you'll return. That's the union type. And then what else? Yeah, this talks about interfaces and how to implement interfaces. using the interface. You can define interface using the interface keyword. And it talks about lists and non-null. Basically, they talk about the difference between something like this, which is an array that can have strings, but none of the strings can be nulls. And in this one, this is an array that is cannot be a null, but the strings can be nulls. And here the array can be null. I mean, here the array can be null. So that's lists and nulls. Enumeration data type. You can define an enum object using enum and the name of the enum and a bunch of values that go in it. I think JavaScript implementations will use integers to map the values. That's like an implementation detail. You can use the scalar data type to create your own scalar types. I think the only supported ones in GraphQL, other than the user-defined ones, are int, float, string, boolean, and id. There are 5 of them. And what else? Scalar data types, and then they talk about the 2 types are again query and mutation. And they talk about how to define a object with which takes arguments. As in this case, length is a field, and it can take unit as one of the arguments, and how to set a default value of the argument. What else? That's it. That's the review of this one. So we'll go to validation next. So uh, I'll take a 10-minute break, and after the break, I'll start. Okay, I'm back. Okay, the next one is validation. So looks like we can do some validations. So let me read what this says. It says, by using the type system, it can be predetermined whether a GraphQL query is valid or not. So this allows servers and clients to effectively inform developers when an invalid query has been created without having to rely on runtime checks. Okay. For our Star Wars example, the file Star Wars validation test.js contains a number of queries demonstrating various invalidities and a test file that can be run to exercise the reference implementation's validator. So what is this file? Let me open another tab and see what this is about. Okay, so they wrote a Okay, so they wrote a bunch of test cases that validate anyway. Before we get to this, into the details of this, I'm guessing they'll explain it in the validation document. So I'll just focus on the validation document. So here they say our Star Wars example, this JS file contains a number of queries demonstrating various invalidities and is a test file that can be run to exercise the reference implementation's validator. To start, let's take a complex valid query. This is a nested query similar to an example from the previous section, but with duplicated fields factored out into a fragment. Okay. So, so basically they have a nested query. So they're querying hero and they want so this is a nested query implementation using fragments. So they want the hero with whatever is in this fragment called name and appearances. So name and appearances has name and appears in. And for that hero, they want the hero's friends and they want the name and appears in for their friends. And looks like the friends have friends. So for each friend, they want to do the same thing. So let's see how this looks like. So basically the first part of it is simple. So they want name appears in, they have friends, and looks like there is a friend for R2D2. R2D2 is the hero. So they want R2D2's first friend is Luke Skywalker. Luke Skywalker has his own friends who are Han Solo, Leia, and C3P0. Oh, and R2D2 is also his friend. So we show that. And same thing, I think, for the rest of them. So that's the nested query they're talking about. And this query is valid. Let's take a look at some invalid queries. A fragment cannot refer to itself or create a cycle, as this could result in an unbounded result. So which is pretty much expected. A fragment cannot refer to itself. So like in this case, you have a fragment called name and appearances and friends. So in this fragment, we are in the friend section, we are trying to refer to the same fragment. So you cannot have a fragment nest itself inside of it, is what these guys are saying. They're saying you cannot spread fragment. Okay. Okay. So when we query for fields, we have to query for a field that exists on the given type. So as hero returns a character, we have to query for a field on character. That type does not have a favorite spaceship field. So this query is invalid. So if you query on something, and if you're trying to query for a field that doesn't exist in an object type like hero, like favorite ship doesn't exist, so it will return an error. So they're saying, hey, this is what will happen. So whenever we query for a field and it returns something other than the scalar or an enum, we need to specify what data we want to get back from the field. Hero returns a character, and we've been requesting fields like name and appears in on it. If we omit that, the query will not be valid. Oh, so we have to specify the fields that we want from a object type, is what they're saying. And here it's throwing an error for that also. Similarly, if a field is a scalar, it doesn't make sense to query for additional fields on it, and doing so will make the query invalid. It makes sense. Name here is a string. It doesn't have anything called first character of name, so it throws an error. So it's a scalar, so it doesn't have any subfields. So earlier it was noted that a query can only query on fields on the type in question. When we query for hero, which returns a character, we can only query for fields that exist on character. What happens if you want to query for R2D2's primary function though? So basically, they're saying this is also an error. This is also an error if, because character type, not all character is an interface, and there are two fragments derived. I think one is called human and the other one is called droid. And only the droid has primary function, but not human. So passing something like this will throw an error also. So that query is invalid because primary function is not a field on character. that query is invalid because primary function is not a field on character. So we want some way of indicating that we wish to fetch primary function if character is a droid and ignore that field otherwise. So we can use the fragments we introduced earlier to do this. By setting up a fragment defined on droid and including it, we ensure that we only query for primary function where it is defined. So in this case, a fragment called droid fields on droid primary function. Okay, so it looks like droid is actually a type object. It's not a fragment. And oh, they created a fragment on it. Okay. So they created a fragment on droid, and then that is returning primary function. Okay. So I wonder what happens if we pass something like Empire. For Empire, I think I'm guessing it will only return Luke Skywalker in the name. It won't return primary function at all. There is no way to check that here because this one is not a fully working one, so there is no way to change it. So the next one is this query is valid, but it's a bit verbose. Named fragments were valuable above when we use them multiple times, but we are only using this once. Instead of using a named fragment, we can use an inline fragment. This still allows us to indicate the type we are querying on, but without naming a separate fragment. So this is how you do a inline fragment. So this is like a inline fragment without a name, and this part of it is a fragment with a name called droid fields. Because we are going to use it only once, they're saying there is no need to create more code. You can just use the spread operator and the on keyword on droid and create an inline fragment. Basically, we are saying, hey, fragment, I only want primary function. So if this hero is has a type, if the hero is of type droid, then we return primary function, otherwise we don't. Okay, so this is the difference between an inline fragment. Inline fragment is not named, and a fragment named fragment. That makes it clear a little more. This has just scratched the surface of the validation system. There are a number of validation rules in place to ensure that a GraphQL is semantically meaningful. The specification goes into more detail about this topic in the validation section. And the validation directory in graphql.js contains code implementing a specification compliant GraphQL validator. Okay. So execution. After being validated, a GraphQL query is executed by a GraphQL server, which returns a result that mirrors the shape of the requested query, typically as JSON. So it looks like if the service has a query, so I think query and mutation are reserved types, object types. Query and mutation are reserved object types. So if you have to define a query, and this is the entry into the service. So if you define a query with something like this, basically you're saying, hey, human, ID is required. You need to pass an ID to get a human, and then human itself is defined as having a name, appears in, and starships. And because appears in is episode, you have to define a enum, and then starship itself is another object type with one field in it called name, which is of the string data type. Okay. So in order to describe what happens when a query is executed, let's use an example to walk through. Human with ID 1002 and name blah blah blah, and it returns Han Solo and all the data. You can think each field in the GraphQL query as a function or method of the previous type, which returns the next type. In fact, this is exactly how GraphQL works. Each field on each type is backed by a function called the resolver, which is provided by the GraphQL server developer. When a field is executed, the corresponding resolver is called to produce the next value. If a field produces a scalar value like a number or like a string or number, then the execution completes. However, if a field produces an object value, then the query will contain another selection of fields which apply to that object. This continues until scalar values are reached. GraphQL queries always end at scalar values. Okay, that makes sense. So because each one is like a method, hey, if the name is a string, so it's a scalar, so it looks like it will be associated with a function called name. And as soon as that function executes, it will not query anything about name further. Appears in is an array, and yeah, because it's not an object, it also doesn't have to do anything further. There will be one function for this. Starships, it has something inside of it. It's not a leaf field. So for starships, it will go and get the starships, and then it will go and get only the names of the starships. Name is the leaf field here, and after that, it's done. So root fields and resolvers. At the top level of every GraphQL server is a type that represents all of the possible entry points into the GraphQL API. It's often called the root type or the query type. In this example, our query type provides a field called human, which accepts the argument ID. The resolver function for this field likely accesses a database and then constructs and returns a human object. So this is a JavaScript notation. So they are creating something. Okay, the query type is nothing but as they were saying. So I don't know. I thought I knew this, but anyway. So it's doing, so query is an object, and inside that object, they have, okay, so they have another function. So this will be another object, I'm guessing, which is doing nothing but it's going to get, it will load human by ID based on the argument that the ID that was passed, and then it will say user data. Okay, it will return this. Understood. So this example is written in JavaScript. However, GraphQL servers can be built in many different languages. A resolver function receives 3 arguments. Object, so looks like this is the human is the resolver function. So object, the previous object which for a field on the root query type is often not used. And the second argument is args, the arguments provided to the field in the GraphQL query. Okay. So I think in this case, ID, in the way we defined the type for human, ID is required. So ID gets passed in, and context, a value which is provided to every resolver and holds important contextual information like the currently logged in user or access to a database. Okay. So asynchronous resolvers. Let's take a look at what's happening in this resolver function. So it has, again, 3 arguments are being passed to this. One is object, the second one is arguments, and the context. So what is object again? Okay. Or the previous object, like the parent object or something. Object is nothing but that. So if you have nested objects or nested fields inside your query, so it looks like the previous object will have the parent object. But for query, because query itself is root, there is nothing inside query. So this will, yeah, we don't use this at all, I think, for the query one. So asynchronous resolvers, I think we'll take a closer look at asynchronous resolvers. So as you can see, context is used to provide access to database, which is used to load the data for a user by the ID provided as an argument in GraphQL query. So context is being used to access the database. I think it's filtering on a where clause. I'm guessing ID is being used as being used in the where clause. Since loading from a database is an asynchronous operation, this returns a promise. Okay, so this is basically returning a promise. In JavaScript, promises are used to work with asynchronous values, but the same concept exists in many languages, often called futures, tasks, or deferred. When the database returns, we can construct and return a new human object. So it looks like when the database, when this promise is resolved, it returns user data. And user data, you're saying, hey, using the user data, return a new human with the user data, is what this is saying. Notice that while the resolver function needs to be aware of promises, the GraphQL query does not. It simply expects the human field to return something which it can then ask the name. During execution, GraphQL will wait for promises, futures, and tasks to complete before continuing, and will do so with optimal concurrency. Trivial resolvers. Now that a human object is available, GraphQL execution can continue with the fields requested on it. Okay, so now that a human object is available, GraphQL execution can continue with the fields requested on it. So human object is available. I don't know what they mean by that. So there is this human. Looks like we need a way to resolve, because they're asking for name also. Looks like we have to create another function for name, which will again take object arguments. I think in this case, we're not filtering on the name and context. And in this case, they're only asking for the name. So this returns object.name. Okay, so this is a simple resolver. So we got to the leaf node. A GraphQL server is powered by a type system, which is used to determine what to do next. Even before the human field returns anything, GraphQL knows that the next step will be to resolve fields on the human type, since the type system tells it that the human field will return a human. Resolving the name in this case is very straightforward. The name resolver function is called, and the object argument is the new human. New human object returned from the previous field. In this case, we expect that human object to have a name property, which we can read and return directly. In fact, many GraphQL libraries will let you omit resolvers. This simple and will just assume that if a resolver isn't provided for a field, that a property of the same name should be read and returned. Okay. They're saying that if it's a simple resolver, then some GraphQL libraries will assume that the name is on the field itself, in this case human, and then it will return the name of the field, the value of the field. So you don't have to write a resolver like name if it's something simple, like if the object itself has a property called name in it, is what they're saying. But I don't know what the best practice there is. Maybe the best practice is always write a resolver function to return, just to be on the safe side. So scalar coercion. While the name field is being resolved, the appears in and starship fields can be resolved concurrently. The appears in field could also have a trivial resolver. But let's take a closer look. Human appears in, so there is another resolver called appears in. So this appears in is returning, in this case, because it's JavaScript, and enum is not a, there is no feature for enum in JavaScript. It's going to return an array with just some IDs. And we have to translate that, I guess. We have to figure out what those IDs really mean. Notice that our type system claims appears in will return enum values with known values. However, this function is returning numbers. Indeed, if we look up at the result, we'll see that the appropriate enum values are being returned. What's going on? This is an example of scalar coercion. The type system knows what to expect and will convert the values returned by a resolver function into something that upholds the API contract. In this case, there may be an enum defined on our server which uses numbers like 4, 5, and 6 internally, but represents them as enum values in the GraphQL type system. Okay, understood. So list resolvers. So we've already seen a bit of what happens when a field returns a list of things with the appears in field above. It returned a list of enum values, and since that's what the type system expected, each item in the list was coerced to the appropriate enum value. What happens when the starships field is resolved? So they're adding another resolver for starship. So starships, so it's returning. So for every ID, we are saying load starship by ID, and that is returning the new starship data. Okay. So basically, this is returning an array of starship data. So the resolver for this field is just returning a promise. It's returning a list of promises. The human object had a list of IDs of the starships they piloted, but we need to go and load all of those IDs to get real starship objects. GraphQL will wait for all of these promises concurrently before continuing. And when we left with a list of objects, when left with a list of objects, it will concurrently continue yet again to load the name field on each of these items. Okay. Producing the result. As each field is resolved, the result value is placed into a key value map with the field name or alias as the key and the resolved value as the value. This continues from the bottom leaf fields of the query all the way back up to the original field of the root query type. Collectively, these produce a structure that mirrors the original query, which can then be sent to the client which requested it. Let's take one last look at the original query to see how resolving functions produce a result. Okay, so understood. The next one is introspection. Let me take a few minutes break and come back. Okay, I'm back. So this section talks about introspection. I wonder how much more. Oh, next one is best practices. Almost getting there, I guess. So let's go to introspection. So introspection, it's often useful to ask GraphQL schema for information about queries it supports. GraphQL allows us to do so using the introspection system. Okay, so for our Star Wars example, the file Star Wars introspection test.js contains a number of queries demonstrating the introspection system and is a test file that can be run to exercise the reference implementation's introspection system. We designed the type system so we know what types are available. But if we didn't, we can ask GraphQL by querying the __ schema field. Yeah, it's always available on the root type of a query. Let's do so now and ask what types are available. So if a query like __ schema with type's name is issued, then it is returning schema types. Okay, these are all the schema types that are available. Query and mutation are always there. So let's find mutation and see if we can find mutation. Yep, there it is. Query and mutation are there in the schema. There is episode. I thought episode is an enum. Character was an interface, if I remember correctly, and ID. I don't know. Oh, so ID. These are all the basic scalar types: ID, string, int. Friends connection is another object type that's defined by the user. Friends edge is the same thing, defined by the user. Page info is another user-defined object type. Boolean is a scalar that's built into the system. It's reserved. Review is another. So review, I think if I remember correctly, this was an input type that was defined. Search result was the union type that was defined. Human was a object type defined, and it was, if I remember correctly, it implements that interface called character. Oh, that length unit is nothing but it's another enum. Yeah, float is it's defined by the system itself, the service itself. And yeah, this one is again defined by the user. Same thing about this next one also. Oh, review input. I think this one is an input type. I think this is different from review itself. I think this is the This is used in mutations. Oh, schema itself is showing up. So type is again, yeah, type is again like a built-in feature, but I don't know what exactly that means. Maybe they define it further. Same thing with type kind. Type kind is again defined. It's system defined. I'm guessing underscore underscore field is similar. Input value is also a system defined schema type, or enum value is similar. Directive is again similar. Directive location, I don't know. We haven't used that so far. So that's a lot of types. And what are they? If we group them, okay, query, character, human, episode, droid. These are the ones that we defined in our system. Really? I thought queries, you have to always define query. Okay, so we defined it. So we didn't, basically we said, okay, type query and type query. And then we said, okay, these are the type of objects available in our type query. Okay, so we did that. Character is an interface that we define. Same thing with human. Episode, I thought it's an enum that we defined. And droid was another object type that implements that character interface, and it's yeah, basically that was again defined by us. So string and boolean are built-in scalars, that we know that. And schema, type kind, field, all the rest of these are all preceded with double underscores, indicating that they're part of the introspection system. Okay, they're part of the introspection system. So now let's try and figure out a good place to start exploring what queries are available. When we designed our type system, we specified what type all queries would start at. Let's ask the introspection system about that. So to figure out what queries are available, so we can ask the introspection system. So in this case, if we do query type name, looks like that will return us all the queries. I wonder if query type is a reserved built-in type. Let me see if there is query type anywhere here. I don't see anything called query type, so I don't understand how this works. So looks like maybe query type. If you do something like this, it'll tell you if there is any object of type query. So maybe that's what is returning here. And that matches what we said in the type system section, that query type is where we will start. Note that the naming here was just by convention. We could have named our query type anything else, and it still would have returned here what we specified it was. It was the starting type for queries. Naming it query, though, is a useful convention. So it's just a convention to call it query. So we can call it anything. I wonder how it will figure out what the entry point is if we define a bunch of object types. Maybe we'll see it down below. So it is often useful to examine one specific type. Let's take a look at the droid type. So this kind of query, if I do a underscore underscore type or underscore underscore type, will give me what kind of type something is, I guess. So I don't know what benefit we get by just doing something like this, because we are saying, hey, give me an object of type droid, and it's returning an object of type droid. What if we want to know more about droid though? For example, is it an interface or an object? Oh, so if I pass in the kind, then it's going to tell me what kind it is. So if I send character here, I'm guessing it'll tell me it's a interface. Yep. Okay. Kind returns a underscore underscore type kind. So can I do something like this then? So it's nothing like this. Type. Okay. Okay. What else is available? So the faces. Fields. Fields, and then I have to specify what kind of fields I want. Is there a name field? So these are the fields inside of character. So ID, name, friends connection appears. Okay. I wonder why I can't do a type kind here. Okay. Kind returns. Oh, should I do a kind instead of that? Okay. Anyway, I still don't understand why some of these. What's the relationship between something like this and something like this? Kind returns a underscore underscore type kind enum. One of those values is object. If we asked about character instead, we find that it's an interface. Okay, understood. So if we pass basically a character, the kind changes to an interface because character is an interface. So it's useful for an object to know what fields are available. So let's ask the introspection system about droid. So introspection, we're asking droid name, fields, name, type, name, kind. Okay. Basically, we can ask what fields are available and the name of the fields, and what is the type of each field. So it's saying ID, it has no name. I don't know why we would ask for name again. So all the names are turning out to be null. Oh, so if it is, I wonder why this is not saying it's an object or something like that. So here it said string, but for none of the others, for appears, should it say array or something? Because it's not it's an array. Hmm. And name, isn't name a string? Shouldn't ID return something like ID? So it's useful for an object to know what fields are available. So let's ask the introspection system. So it's saying, hey, there is an object called droid. The droid has fields name and it's of type ID. Oh no, it's not even type ID. The name of the field itself is ID. So name of it is ID. So the name of the field itself is ID. And if you look at the type it's saying not null, but it doesn't say, I don't know why this doesn't say ID. Anyway, if you go through the rest of it, those are our fields that we defined on Android. I understand that, but I don't know why this type is not saying what is the type name. I think all of them have names, right? So shouldn't this be a string? I thought that should be a string. And friends, I think, okay, its kind is list, but name is null. Anyway, this is a little confusing, but maybe they'll explain it further down the page. So those are our fields that we defined on Droid. ID looks a bit weird. It has no name for type. That's because it's a wrapper type of kind non-null. If we queried for off type on that field's type, we would find ID type there. Really? Yeah, I can't do that. So I don't know why that is null. Oh, and this one has something in it. So, okay, so for name also it's showing that it is a string. And for friends, it's showing its character. Okay. Friends connection, its type is friends connection. Appears in is still null. Primary function of type null. Okay. Because it's scalar, there is no there is no further subtype, I guess. Similarly, both friends and appears in have no name since they are the list wrapper type. We can query for off type on those types, which will tell us what these are lists of. Okay, let's see what friends is. Okay, so it's a list of characters. Okay. Oh, so you can also do a kind on off type, huh? Okay. So if you do a kind on off type, it's telling, it's giving you a little more details. For ID, oh, it's saying that it's a scalar. I don't know why. Name. In some cases, name is string. For string, I think it did say name is string. Of type is null. Anyway, so as we go further, maybe we'll understand this better. So type for appears in, because it's a list, it's saying kind is a list. Okay. Name is null again. So for some of them, name is an object. So it's saying, hey, this is friends connection object. Okay. So friends is nothing but a list of characters. So that's what it's saying. So let's end with a feature of the introspection system particularly useful for tooling. Let's ask the system for documentation. So you can actually describe each of your object types with a description field. So it looks like if you defined, when you defined your object types, if you have an object type, looks like there is a description. You can give it a description field. So, and put something in there, and then that's where you get the documentation from. So what else can I ask? Name and of type. Oh, droid is an object. So that's where it is. We can access the documentation about the type system using introspection and create documentation browsers or rich IDEs. Okay. So earlier we saw one of the IDEs they created. This has just scratched the surface of the introspection system. We can query for enum values, what interfaces a type implements, and more. We can even introspect on the introspection system itself. I think the specification goes into more detail about this topic in introspection section. And the introspection file in GraphQL.js contains code implementing a specification compliant GraphQL query introspection system. Okay. Let's look at the best practices. GraphQL best practices. GraphQL specification is intentionally silent on a handful of important issues facing APIs, such as dealing with the network authorization and pagination. This doesn't mean that there aren't solutions for these issues when using GraphQL, just that they're outside the description about what GraphQL is and instead just common practice. Okay. The articles in this section should not be taken as gospel. And in some cases, may rightfully be ignored in favor of some other approach. Some articles introduce some of the philosophy developed within Facebook around designing and deploying GraphQL services, while others are more tactical suggestions for solving common problems like serving over HTTP and performing authorization. Following are brief descriptions of some of the more common best practices and opinionated stances held by GraphQL services. However, each article in this section will go into more depth on these and other topics. HTTP GraphQL is typically served over HTTP via a single endpoint which expresses the full set of capabilities of the service. Okay. This is in contrast to REST APIs, which expose a suite of URLs, each of which expose a single resource. That's cool. So there is only a single URL, and based on the types that are defined, based on your schema, you query for what you need, I guess. That's really good. While GraphQL could be used alongside a suite of resource URLs, this can make it harder to use with tools like GraphIQL. Read more over serving over HTTP. Let me briefly look at what they mean. Oh, okay. So we are going to go to that section anyway. So looks like, yeah. So we will get there after this best practices introduction. So I don't want to jump ship yet. JSON with gzip. GraphQL services typically respond using JSON. However, the GraphQL spec does not require it. JSON may seem like an odd choice for an API layer promising better network performance. However, because it's mostly text, it compresses exceptionally well with gzip. It's encouraged that any production GraphQL services enable gzip and encourage their clients to send the header accept encoding gzip. Okay. JSON is also very familiar to client and API developers and is easy to read and debug. In fact, the GraphQL syntax is partly inspired by the JSON syntax. So basically they're saying, okay, we respond using JSON-like format, which is good. The only thing is we need to make sure that on we enable gzip. So for versioning, so you can still version the service just like any other REST APIs. So, but here there is a strong opinion on avoiding versioning. So basically, we continuously evolve the schema, but I think we should not depend. We should avoid versioning. Just evolve the schema over time. So, but okay. So here they're talking about why was even versioning implemented. So when there is limited control over data, then any change is considered a breaking change. That's the reason why they have multiple you keep on adding new versions of it so that whoever is using your API, yeah, so it won't be a breaking change for the consumers. So if adding new features to an API require a new version, then a trade-off emerges, right? So, but for GraphQL, we only return data that's explicitly requested. We can add new capabilities and new fields to those without breaking anything that's pre-existing. So basically, this will be a versionless API, no breaking changes. So when it comes to nullability, so in this GraphQL system, every field is nullable. So because this is backed up, this is a service over the network backed by a database, I think yeah, any field can be null. Yeah. Yeah. So also, yeah, the fields, because if it's based on an authorization system, then you can return some fields, but not other fields based on your authorization level. So some fields can be null. By defaulting every field to nullable, any of these reasons may result in just that field returned null rather than having a complete failure for the request. Instead, GraphQL provides non-null variants of types, which make a guarantee to clients that if requested, the field will never return null. Okay. So here we can use that exclamation to make sure that for a particular field, a null is not accepted. So you can use that to enforce nullability or non-nullability. So we talk about pagination also. Okay. I think we reviewed this already, right? Okay. I'll talk about more of it here. How did we skip this? Oh, it's there at the bottom. There are a bunch of other best practices. Let me take like a 5-minute break. I'll be back in 5 minutes. Let me get some coffee. So we talked about nullability. Now we'll go to pagination. So for pagination, the GraphQL type system allows for some fields to return list of values. However, leaves the pagination of longer lists of values up to the API designer. There are a wide range of possible API designs for pagination, each of which has pros and cons. Typically, fields that could return long lists accept arguments first and after to allow for specifying a specific region of a list, where after is a unique identifier of each of the values in the list. Ultimately, designing APIs with feature-rich pagination led to a best practice pattern called connections. Some client tools for GraphQL, such as Relay, know about the connections pattern and can automatically provide automatic support for client-side pagination when a GraphQL API employs this pattern. Looks like you have to look into what this is. And Relay. So Relay is a client-side library, I'm guessing. A JavaScript framework for building data-driven React applications. Darn. So I don't know what this is. It's declarative collocation mutations. Declare the data your components read with GraphQL. Relay determines how and when to fetch data. Collocation. GraphQL is returned next to the views that relay on them. Anyway, this relay thing, you have to look at this relay later. So you have to use relay and the connections pattern to do pagination. The next part of it is server-side batching and caching. GraphQL is designed in a way that allows you to write clean code on the server where every field on every type has a focused single-purpose function for resolving that value. However, without additional consideration, a native GraphQL service could be very chatty or repeatedly load data from your databases. This is commonly solved by a batching technique where multiple requests for data from a backend are collected over a short period of time and dispatched in a single request to an underlying database or microservice by using a tool like Facebook's data loader. What? Is part of your application's data fetching layer to provide a consistent API over various backends and reduce requests to those backends via batching and caching. Data loader is a generic utility to be used as part of your application's data fetching layer to provide a simplified and consistent API over various remote data sources such as databases or web services via batching and caching. Clearing the cache. In certain uncommon cases, clearing the request cache may be necessary. Caching errors. Disabling cache. API. Great. Nice.
Hey everyone, I'm going to do a little bit of a screencast today. We were discussing some techniques that we had used, and we were really hoping for like a dialogue between, ways that they solve their problems, hopefully different from ways that we solved our problems. To be written by your friend, and we want to show their name and profile picture. And on another part of the like that, here's where you do that.
Okay.
And then we're going to
I'll look at this later. So we'll go to this thinking in graphs. Thinking in graphs. Graphs all the way down. With GraphQL, you model your business domain as a graph. Graphs are powerful tools for modeling many real-world phenomena because they resemble our natural mental models. and verbal descriptions of the underlying process. With GraphQL, you model your business domain as a graph by defining a schema. Within your schema, you define different types of nodes and how they connect, relate to one another. On the client, this creates a pattern similar to object-oriented programming, types that reference other types. On the server, since GraphQL only defines the interface, you have freedom to use it with any backend, new or legacy. Okay. Shared language. So basically what they're saying is you define your graph and object types and how the objects interact or what the dependencies are, and that's it. After that, anyone can query if they know your, if you expose your schema, then actually people can query for your schema and then figure it out also. For example, so that they're saying there is a shared language. Think of your GraphQL schema as an expressive shared language for your team and your users. So to build a good schema, examine the everyday language you use to describe your business. For example, let's try to describe an email app in plain English. A user can have multiple email accounts. Each email account has an address, inbox, drafts, deleted items, and sent items. Okay. You have a user at a high level, and within a user, you have accounts, I guess, email accounts in this case, which will be an array, and each email account will have address, inbox, drafts, blah, blah, blah. Each email has a sender. We see within each email, you have a sender, receive, date, subject, body. Users cannot send an email without a recipient address. Okay. Naming things is a hard but important part of building intuitive APIs. So take time to carefully think about what makes sense for your problem domain and users. Your team should develop a shared understanding and consensus of these business domain rules, because you will need to choose intuitive, durable names for nodes and relationships in the GraphQL schema. Try to imagine some of the queries you will want to execute. Fetch the number of 100 emails in my inbox for all my accounts. Okay. So basically everything should be everything should have, yeah. So saying make sure the names of the nodes are durable and relationships in GraphQL schema. So fetch the preview info for the first 20 drafts in the main account. Okay. So basically, these are some of the best practices, the naming convention and the relationships. You have to define it pretty good. And in this case, we are using a fragment. So everything has to be properly defined is what they're saying. The business logic layer. Your business logic layer should act as the single source of truth for enforcing business domain rules. Where should you define the actual business logic? So basically they're saying, hey, this is where the business logic layer should act as the single source of truth for enforcing business domain rules. The answer, inside a dedicated business logic layer, your domain logic layer should act as the single source of truth for enforcing business domain rules. Okay. So basically persistence is the database layer, and looks like the GraphQL layer will be talking to the business logic layer to get the data from the persistence layer. Persistence layer is nothing but the database. In the diagram above, all entry points into the system will be processed with the same validation, authorization, and error handling rules. Working with legacy data. Prefer building a GraphQL schema that describes how clients use the data rather than mirroring the legacy database schema. Sometimes you will find yourself working with legacy data sources that do not perfectly reflect how clients consume the data. In these cases, prefer building a GraphQL schema that describes how clients use the data rather than mirroring the legacy database schema. Build your GraphQL schema to express what rather than how. Then you can improve your implementation details without breaking the interface with older clients. One step at a time. Get validation and feedback more frequently. Don't try to model your entire business domain in one sitting. Rather, build only the part of the schema that you need for one scenario at a time. By gradually expanding the schema, you will get validation and feedback more frequently to steer you towards building the right solution. Okay. Serving over HTTP. HTTP is the most common choice for client-server protocol when using GraphQL because of its ubiquity. Here are some guidelines for setting up a GraphQL server to operate over HTTP. Web request pipeline. Most modern web frameworks use a pipeline model where requests are passed through a stack of middleware. Filter plugins. As the request flows through the pipeline, it can be inspected, transformed, and modified or terminated with a response. GraphQL should be placed after all authentication so that you have access to the same session and user information you would in your HTTP endpoint handlers. Okay. So basically, you should make sure the user is authorized we finish the, yeah, make sure that the user is authenticated, and then only GraphQL query should be called. I think without authentication, you should not expose your GraphQL service, is what they're saying, which makes sense because, yeah, the URIs routes, HTTP is commonly associated with REST, which uses resources as its core concept. In contrast, GraphQL's conceptual model is an entity graph. As a result, entities in GraphQL are not identified by URLs. Instead, a GraphQL server operates on a single URL endpoint, usually /GraphQL, and all GraphQL requests for a given service should be directed at this endpoint. So they're saying that GraphQL basically usually operates on a single URL endpoint. So HTTP methods, headers, and body. Your GraphQL HTTP server should handle the HTTP get and post methods. Get request. When receiving an HTTP get request, the GraphQL query should be specified in the query string. For example, if we wanted to execute the following GraphQL, this request could be sent via an HTTP get. So like, okay. So it looks like they're saying that if you want to answering a text message, 1 second. When receiving an HTTP GET request, the GraphQL okay. It's saying this request could be sent via an HTTP GET. So like this, query variables can be sent as JSON encoded string. Okay. In an additional query parameter called variables. The query contains several named operations. An operation name query parameter can be used to control which one should be executed. Okay. Post request, a standard GraphQL post request should use the application JSON content type and include a JSON encoded body of the following form. Okay. Hmm. They're saying your GraphQL HTTP server should handle the HTTP GET and POST methods. I don't know. I do not understand this properly, but let me see. So here they're saying operation name and variables are optional fields. Operation name is only required if multiple operations are present in the query. So in addition to the above, we recommend supporting two additional cases. If the query string parameter is present, as in the get example above, it should be parsed and handled in the same way as the HTTP GET case. So the post should handle something like the post should also handle a query string parameter is what they're saying. If application GraphQL content type header is present, treat HTTP post body contents as the GraphQL query string. If you're using Express GraphQL, you already get these behaviors for free. Ooh, so just use Express GraphQL response, regardless of the method by which the query and variables were sent. The response should be returned in the body of the request in JSON format. Oops. Regardless of the method by which the query and variables were sent, response should be returned in the body of the request in JSON format. Okay, basically they're saying the data and errors go back in the body. Oh, sorry, in the body of the request in JSON format. As mentioned in the spec, a query might result in some data and some errors, and those should be returned in a JSON object of the form. If there were no errors returned, the errors field should not be present on the response. Okay. If no data is returned according to the GraphQL spec, data field should only be included if the error occurred during execution. GraphIQL. GraphIQL is useful during testing and development, but should be disabled in production by default. If you're using Express GraphQL, you can toggle it based on the node env environment variable. Okay. If you're using Node.js, we recommend using either Express GraphQL or Express Server. Okay. What is the difference? GraphQL Server for Express Connect, Happy, Koa, Restify, and AWS Lambda. GraphQL Server is a community-maintained open-source GraphQL server. It works with all Node.js HTTP server frameworks. GraphQL Server is built with the following principles in mind: by the community, for the community, simplicity, performance. Okay. Okay. So if we use Express or Lambda, okay. Lambda function should be run with Node.js 4.3. Requires an API gateway with Lambda proxy integration. Anyway, we'll look at this later. So this one is just a package. Okay, we'll have to dig into this further later, I guess. Authorization, delegate authorization logic to the business logic layer. Authorization is a type of business logic that describes whether a given user session context has permission to perform an action or see a piece of data. For example, only authors can see their drafts. Okay. Enforcing this kind of behavior should happen in the business logic layer. It's tempting to place authorization logic in the GraphQL layer like so. Notice that we define author owns a post by checking whether the post's author ID field saying post fields body resolve. Where is it being done here? Authorization logic in the GraphQL layer like so. I don't see authorization logic. Where is authorization logic? Context.user. Okay, this is what it's saying. Only if the user is post's author. Notice that we define author owns a post by checking whether the post's author ID field equals the current user's ID. They're saying that we shouldn't be doing something like this. Can you spot the problem? We would need to duplicate this code for each entry point into the service. Then, if authorization logic is not kept perfectly in sync, users could see different data depending on which API they use. Yikes. We can avoid that by having a single source of truth for authorization. Defining authorization logic inside the resolver is fine when learning GraphQL for prototyping. However, for production code base, delegate authorization logic to the business logic layer. Here is an example. So they're basically calling the business logic with user, yeah, and post. So there is no logic here. The business logic will check if the user is the author of the post and then return the post. In the example above, we see that the business logic layer requires the caller to provide a user object. If you are using GraphQL.js, the user object should be populated on the context argument or root value in the fourth argument of the resolver. We recommend passing a fully hydrated user object instead of an opaque token or API key to your business logic layer. This way, we can handle the distinct concerns of authentication and authorization in different stages processing pipeline. Pagination. Pagination, different pagination model enable different client capabilities. A common use case in GraphQL is traversing the relationship between sets of objects. There are a number of different ways that these relationships can be exposed in GraphQL, giving a varying set of capabilities to the client developer. Plurals. The most simple way to expose a connection between objects is with a field that returns a plural type. For example,
Found that use for those mentions.
okay. So the most simple way to expose a connection between objects is with a field that returns a plural type. For example, if we wanted to get a list of R2D2's friends, we could just ask for all of them. Okay. Slicing quickly, though, we realize that there are additional behaviors a client might want. A client might want to be able to specify how many friends they want to fetch. Maybe they only want the first two. So we'd want to expose something like first two. But if we just fetch the first two, we might want to paginate through the list as well. So once the client fetches the first two friends, they might want to send a second request to ask for the next two friends. How do we enable that behavior? So there are a number of ways we could do pagination. We could do something like friends first two offset two. We could do something like after friend ID first two after friend ID to ask the next two. We could do something like friends after friend cursor, where we get a cursor from the last item and use that to paginate. In general, we found that cursor-based pagination is the most powerful of those designs, especially if the cursors are opaque. Either offset or ID-based pagination can be implemented using cursor-based pagination. By making the cursor the offset or the ID, and using cursor gives additional flexibility if the pagination model changes in the future. As a reminder that the cursors are opaque and that their format should not be relied upon, we suggest base64 encoding them. As a reminder that the cursors are opaque and that their format should not be relied on. Okay, that leads us to a problem. Though, how do we get the cursor from the object? We won't want cursor to live on the user type. It's a property of the connection, not of the object. So we might want to introduce a new layer of indirection. Our friends field should give us a list of edges, and an edge has both a cursor and the underlying node. The concept of an edge also proves useful if there is information that is specific to the edge rather than to one of the objects. For example, if we wanted to expose friendship time in the API, having it live on the edge is a natural place to put it. End of list. End of list counts and connections. Now we have the ability to paginate through the connection using cursors. But how do we know when we reach the end of the connection? We have to keep querying until we get an empty list back. But we'll really like for the connection to tell us when we've reached the end. So we don't need that additional request. Similarly, what if we want to know additional information about the connection itself? For example, how many total friends does R2D2 have? To solve both these problems, our friends field can return a connection object. The connection object will then have field for the edges as well as other information, like total count and information about whether a next page exists. Okay, so the final query might look something like this. So basically, we're saying have an I has next page and end cursor, and the edges themselves have name and cursor. And the total count is one of the fields. So let's see. Note that we also might include end cursor and start cursor in this page info object. Okay, so they're saying this could have an start cursor also. This way, if we don't need any of the additional information that the edge contains, we don't need to query for the edges at all, since we got the cursors needed for pagination from page info. This leads to a potential usability improvement for connections. Instead of just exposing the edges list, we could also expose a dedicated list of just the nodes to avoid a layer of indirection. Complete connection model. Clearly, this is more complex than our original design of just having a plural. But by adopting this design, we have unlocked a number of capabilities for the client. The ability to paginate through the list, the ability to ask for information about the connection itself, like total count or page info, the ability to ask for information about the edge itself, like cursor or friendship time, the ability to change how our backend does pagination, since the user just uses opaque cursors. To see this in action, there is an additional field in the example schema called friends connection that exposes all of these concepts. You can check it out. You can check it out in the example query by try removing the after parameter to friends connection to see how the pagination will be affected. Also, try replacing the edges. See this in action. There is an additional field in the example schema called friends connection that exposes all of these concepts. Also, try replacing the edges field with the helper friends field on the connection. La 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 da da ra, ra, ra. Wow. That's you there. Additional edge layer of indirection, and that's appropriate for clients. Okay. Yeah, and caching is the last topic. Providing object identifiers allows clients to build rich caches. In the endpoint API, clients can use HTTP caching to easily avoid refetching and for identifying when two resources are the same. The URL in these APIs is a globally unique identifier that the client can leverage to build a cache. In GraphQL, though, there is no URL-like primitive that provides this globally unique identifier for a given object. It's hence a best practice for the API to expose such an identifier for clients to use. Globally unique IDs. One possible pattern for this is reserving a field like ID to be a globally unique identifier. The example schema used throughout these docs uses this approach. Okay, this is a powerful tool to hand to the client developers in the same way that the URLs of a resource-based API provide a globally unique key. The ID field in the system provides a globally unique key. If the backend uses something like UUIDs for identifiers, then exposing this globally unique ID may be very straightforward. If the backend doesn't have a globally unique ID for every object already, the GraphQL layer might have to construct this. Oftentimes, that is as simple as appending the name of the type to the ID and using that as the identifier. The server might then make that ID opaque by base 64 encoding it. Blah, blah, blah. Did not understand that. Anyway, compatibility with existing APIs. One concern with using the ID field for this purpose is how a client using the GraphQL API would work with existing APIs. For example, if our existing API accepted a type-specific ID, but our GraphQL API uses globally unique IDs, then using both at once can be tricky. So in these cases, the GraphQL API can expose the previous API's IDs in a separate field. This gives us the best of the both worlds. GraphQL clients can continue to rely on a consistent mechanism for getting a globally unique ID. Clients that need to work with our previous API can also fetch previous API ID from the object and use that. Alternatives. While globally unique IDs have proven to be a powerful pattern in the past, they are not the only pattern that can be used, nor are they right for every situation. The really critical functionality that the client needs is the ability to derive a globally unique identifier for their caching. While having the server derive that ID simplifies the client can also derive the identifier. Oftentimes, this would be as simple as combining the type of the object queried with underscore underscore type name with some type unique identifier. Additionally, if replacing an existing API with a GraphQL API, it may be confusing if all of the fields in GraphQL are the same except ID, which changed to be globally unique. This would be another reason one might choose not to use ID